Hello students. Okay, this video clip is the next video that I will teach you about the vector quantity. Okay, as you studied previously that we have two kinds of quantity. The first one is scalar and the second one is vector quantity. Vector quantity, there must have both magnitude and direction. So here we have to start with the symbol of vector first. For all kinds of vector quantity, when we draw or we would like to represent that kind of quantity, that kind of vector quantity, uh, we have to draw the straight line with the arrowhead. Okay, here is the symbol of vector quantity. Okay, what can we draw vector quantity? Suppose that we have a vector. I would like to draw this vector. Okay, this is vector and I will let this vector names as vector A. Okay, this is vector A. Suppose that I do have another vector and its direction is like this one. Here I will suppose that it is vector B. From these two vectors we can see that they have the same direction but different magnitude or different size, different length. So it means that the magnitude of vector A and B are different. Or we can say that the magnitude of B is greater than magnitude of vector A. Okay, we can have another vector. Here, vector A, its direction is northeast. But suppose I do have another vector that look like this one. And I will let this vector name as vector C. So we can say that vector C direction is point to the right, or maybe we can call its direction is east direction. Okay, next is equal vector. What about equal vectors? Equal vectors, if we have vectors that are equal, it means that those vectors have same magnitude and direction. Okay, they have same magnitude and same direction. Okay, I will draw another vector. Now I will suppose that uh, this is vector A. Okay, vector A, its direction look like this one. Suppose I have another vectors that have the same direction as A, but suppose that here I will let it as vector B, and suppose that vector B magnitude is twice as magnitude of A, or length of B is 2 times of A. In this case, we can conclude that, or we can write as A 2A equal to B, or we can say that vector B equal to 2 times of vector A. In this case, it means that vector B has the same direction as vector A, but magnitude of B is 2 times of A. Okay, what about opposite vector? When the vectors that are opposite, it means that they have the opposite direction. Okay, I will suppose the same as the previous example. Still have vector A and its direction look like this one. Suppose that now I have another vector that have the same magnitude as A, but opposite as A. Same magnitude as A, but opposite to A. Okay, opposite to A. Here, I will let it as vector B. In this case, I can summarize that vector A equal to negative B. Negative B means that vector B has the same magnitude as A but opposite direction to A. Or if I draw another vectors that are the magnitude are twice as A but opposite direction to A. Okay, I let it as vector C. In this case, I can summarize that vector C vector C equal to negative 2 times of vector A. Okay, or negative C equal to 2A. We can express either one. Okay, now you understand the equal vectors and opposite vector already. So then, suppose we have many vectors and then we would like to add them all together. Okay, add them all together and what will be the result between 2 or 3 or 4 vectors that add all together? Actually, if we have scalar quantities, we don't need to study how to determine the addition of vector because for scalar quantity, we can add the magnitude of them all together or subtract them from each other easily. For example, suppose that we have a tile range 10 centimeter and then we cut off for 2 centimeter. The less that we have is 10 minus 2 or equal to 8. Or maybe suppose we have a tile that half the range is 10 and we add 2 more centimeter. The result is 12 centimeter. But what if we have force 10 Newton and exert or acting or is pulling an object? And if there is another force 2 Newton exert to the same object, how much is the resultant between those two forces? Some of you may answer 12. Okay, but actually it cannot, it may not be 12. It can be other values because it depends on the direction of two force. For example, suppose that I have force. Now I will draw here. I will draw in this area. Okay, suppose I have an object, a box, and it is exerted by force 10 Newton. Suppose we add another 2 Newton to this box. What will be the answer? Okay, 10 Newton. It's much delay. I don't know what happened. Suppose that now I will add 2 more Newton to this object. What will be the resultant vector on this object? It can be either 2. Suppose I exert force 2 Newton in this direction. Okay, yes, the resultant will be 12. But what if I exert force in the opposite direction? I think that most of you know that the resultants between these two forces will be 8 Newton. Okay, but what if I change the direction? Okay, if I change the direction of 2 Newton into this direction instead, okay, what will be the resultant vector between these two forces? Or if I have another force, 5 Newton, act on this object, so what will be the resultant? Okay, here is why I will teach you how to determine the resultant vector. Okay, resultant vector. So when we would like to determine the resultant vector, it means that we are going to determine the addition of vectors. We can determine the resultant vector by using drawing method and calculation method. Here, I will teach you the drawing method first. For drawing method to draw the resultant vector, we can also separate or classify into two methods. Okay, the first one we call head to tail method, and the second one of drawing method we call tail to tail or parallelogram. Okay, let's see the first method first by head to tail. Head to tail method, how to do is first we have to connect tail of the second vector to head of the first vector. And then suppose we have three vectors. So we have to connect for the next step. We have to connect next vector. Next vector here means the third vector. I mean connect tail of the third vector to head of the second vector. Okay, until the last. And then the resultant vector will start from tail of the first vector to head of the last vector. Okay, here I will show you two examples. For the first example, suppose that I let this vector as vector A and this vector is B. Okay, I would like to draw the resultants between vector A and B, or I will add vector A with vector B. What is the result? To draw the resultant vector, you have to follow this step. Okay. First, you have to draw either vector. You can start from vector A or vector B. The result will be the same because it's similar to when we have 2 plus 3, you can determine 2 plus 3 or 3 plus 2. They all have the same result. So here we can draw A and then follow with B, or we can draw B first and then follow with vector A. Okay, here I will draw vector A first. You have to copy vector A, same magnitude, same direction. Okay, here suppose that I draw vector A, same magnitude and direction as this original vector. And what will I do next? I will connect tail of vector B. Okay, before I go into that, I'm sorry. For vector, we call this as tail, and this is head of vector. Okay, next I will connect this vector. I mean connect tail of vector B to head of A. So I will move this vector here. Okay, so it will be look like this one. This is vector B. Okay, next I will draw vector B. Vector B should look like this one. This is vector B. Okay, vector B is here. Now it is already connect to vector A. We have only two vectors, so we connect just only two vectors. The resultants will start from tail of A and end at B. You must draw straight line, start from tail of A and end at head of B. Okay, so you have to draw. Here I will use the red color to represent my resultants. Okay, I will start from vector A and at B. This is my vector, resultant vector. And then you have to draw arrowhead. This is arrowhead Okay, start from tail of the first vector and pointing to head of the last vector. This is very important. Don't forget to draw arrowhead. It must point to the same direction. It must be at the same point as head of the last vector. Okay, here is the resultant of A plus B. If you start with vector B first and follow with A, you will get the same resultant as this vector. Okay? Example 1.3. Sorry, example 2 of, example 2 of example 1.3. Here we have three vectors, and I will let this is vector A, this is vector B, and this is vector C. And we need to draw the resultants between A plus B plus C. What will be our result? We can start with A, follow with B, follow with C, or B, then follow with A, then follow with C. Okay, but here I will suppose that I will draw B first. Okay, I will start with vector B first. Vector B look like this one, so I will copy this vector here. Okay, my vector B should look like this one. Okay, this is vector B. And then follow with vector A. Our vector A point to the right as this one. So then I will connect A here. Okay, I will draw vector A, straight line point to the right. Okay, this is my vector A. Vector A look like this one. It already connects, tail of A is connected to head of vector B. Then we will draw the last vector. Connect tail of last vector. Here is vector C to head of the second vector. Our second vector is vector A. So now I will connect tail of C to head of A. Tail of C. Our vector C, it looks like this one. So I will move vector C here. Okay. Now I will draw vector C, which is in this direction. My vector C is here. Okay, well, where is our resultant vector? Our resultant vector must draw straight line from tail of vector B and at head of vector C, or draw straight line from here to here. Okay, I will use the red color to draw this straight line to represent our resultant. Actually, it should be close to each other. Don't have the gap, okay? We should not have the gap between these two. Between these two. But from my application, it will be look like this one. It's okay. This is the resultant of vector B plus vector A plus vector C. Or sometimes we will write it as R. R means resultant vector. Okay. Here are two examples of drawing method that we call head to tail method. The next page is practice 1.2. Okay, there are 8 problems. I will let you all do as your homework. Okay, and then you have to submit to me. But how to submit, I will tell you in details in the comment again. Okay, please read the instruction carefully. Okay, and I will teach you the next video clip about how to draw addition of vector by parallelogram. Okay, so this video clip I will finish it now. See you next video clip.